Okay, hi, grade ninth. You know how I make up fake questions? Because I say I'm not going to do your homework for you? Yeah, I'm going to do this one for you. Okay, I tried making up with Zaina, Amelie, and Nevea, and the numbers got crazy. It turned out like Nevea turned into like a hobbit, and Zaina was the size of a two-story building. So, anyways, I couldn't make the numbers work, the fractions. It was getting tricky, and I'm like, to heck with it. I'll just show these kids how to do the real question. So, let's get into it. Alan's height is 4/5. So what you want to do, guys, is you want to, again, this is about relationships. Okay, so it's about relationships. You've got to draw connections, relationships, and you've got to draw connections. Okay, I'm trying to use a little handy dandy diagram here because I just so happen to have a library bank of symbols in this program, and I thought, what the heck? It seems to me by reading this, Alan's height is 4/5 of the father's height. Alan's older brother is 6 centimeters taller than Alan. Those two sentences alone have given me an indication that Alan is the shortest one here. Ben is 6 centimeters taller than Alan, so Ben's got to be the orange or the black one. So Ben's height is 5/6 of the father's height. So Ben, this is kind of like the Goldilocks. Um, and then there's a sort of a short, medium, and tall. So this must be father. Okay. All right. So Alan is, let's just actually translate this. Alan's height is 4/5 of his father. Alan's older brother is 6 centimeters taller. Okay. So connecting. Let's draw an arrow to from Alan to father. He is 4/5 of his father's height. Okay. Remember the word of, right? If I tell you Mr. Smith gets 2/3 of like $1 million, right? Oops, need 6 zeros there. If I get 2/3 of $1 million, well, of means times, right? That's what we're saying. We're saying 2/3 of 1 million. I'm not going to draw it all out. Okay, the point is you got 4/5 of father's height. All right, so just erasing all that. Now let's go to the next one. Ben is whatever Alan's height is, he's 6 centimeters taller. Okay. And Ben is also, looks like Ben is kind of the key figure here, is 5/6 of father's height. Okay. So how tall, and it says, how tall is your father? Well, it seems to be kind of just staring you right in the face that they want father's height to be X. So let X. Actually, do you want to just use F? Let's use F for father. Okay, let F equal, it's kind of a common thing to use the small letters, not the big letters, okay? So father's height. Okay, so Alan, let's see. Alan is 4/5 of F. Now watch this. Ben, okay, who is mentioned twice here? Ben, right? Ben is mentioned twice. So guess what? We can write two statements about Ben. This is key, okay? Usually when you're doing these height questions, there's going to be someone in this height question who is the key to solving it. And it's, in this case, it's the one that's mentioned most. So on one hand, okay, Ben is 6 centimeters more than Alan's height. Now we fully admit, I fully admit, you fully admit, we don't know what Alan's height is, but we have an expression, and that for now is actually good enough. So Alan's height, which we don't know, is 4/5 of father's height, add 6. So whatever this is, if he's a 15-foot giant, Ben's 15 feet plus 6 centimeters. Okay? I don't know what Alan's height is, but it's good enough. It's good enough to have the expression. Okay? So on one hand, okay, we've got one way of talking about Ben's relationship to someone else. On the other hand, okay, Ben. So on one hand, Ben's relationship to his brother Alan is 4/5 his father's height plus 6. because we already know how Alan is related to his dad in terms of height. Okay, so Ben, on the other hand, I'm just going to erase this and rewrite it down here just because I want more room. On the other hand, and I'll just keep my color, that'll be good. On the other hand, Ben is not 4/5, pardon me, 5/6. I was able to catch my mistake there. Is 5/6 of his father's height. Okay. So really, we've got two ways of making this relationship between Ben compared to himself. That's kind of the key. So let me write it over here, like in terms of an equation. On one hand, Ben is 4/5. Okay, we're talking about his father's height. Just hang on a sec. And on the other hand, okay, he's 5/6 of his father's height. Okay, I'm just going to pause here for a sec. I shall be right back. Okay, so I just need to gather my thoughts there for a sec. So on one hand, we have one way of defining Ben's height. Okay, this is one way of talking about Ben's height. Okay, on the other, so what is Ben's height? Well, Ben's height is 6 centimeters more than his brother Alan's height. That's one way to get Ben's height. On the other hand, this is Ben's height redefined from a different point of view. Okay, Ben's height, but it's with relationship to his father. But the bottom line, grade 9s, is this. We've had, well, let's just choose this one. No, this one. Ben's height is Ben's height. Okay, so on the left side of the equation, if Ben is 176 centimeters, we have an expression that should, when it's all calculated and the variables are isolated, and we've dealt with the constants, we've dealt with the coefficients, and we isolate the variable, we should get an answer, and I'm just making this up. I don't know the actual answer, but let's say if it was 176. On one hand, we know that 176 centimeters is defined by his height, his relationship to his brother's height at 6. On the other hand, the number 176 would pop up because we're doing 5/6 of his dad's height. Okay, so we have two separate expressions of expressing Ben's height. This is the key to connecting everything through our relationships. Okay, that's how you solve a lot of these problems, whether they're coin problems, distance, speed problems, height problems. You've got to make these connections. Okay, you've got this unknown. You use it twice, in one instance this way, in one instance this way, and they end up being equal to each other. Ben's height is Ben's height. It's just in one respect, we define it according to his younger brother. In another respect, we define it according to how tall is he compared to his dad, compared to his brother, compared to his dad, but it should be the same height. And the nice thing is we've been able to use the father's variable in a manner that we've got a single variable. Remember, at the beginning, don't know Alan's height, don't know Ben's height, don't know the father's height. That's 3 unknowns. How the heck are you going to solve that? By connecting the unknowns to a single unknown. So let F equal the father's height, and everything's based off that relation, off that variable, and connecting the relationships. All right, let's go. So on one hand, we've got 4/5 F plus 6 is equal to 5/6 F. Okay, well, why don't I subtract 4/5 from both sides? Okay, because this is already, and I'm just going to switch colors here briefly. We're going to subtract 4/5 from both sides. All right, and because this one's already sort of by itself, so why not? There's no sense in dealing with the constant. Let's have the constant be by itself, and let's isolate the variable at the same time. We kind of killing 2 birds with 1 stone. 4/5 F minus 4/5 F. So this is positive. This is a negative, really, they just cancel each other out. And we're left with 6 is equal to, okay, now I'm going to change the style of writing. It's going to be 5. You're going to put the f up on the numerator, minus 4f over 5. And yes, we do have a little issue to contend with here. We need this lowest common denominator. So I'm going to pause now again because I want to create some room so I can do this whole fraction thing. Okay, I shall return. Okay, see, this was hidden a little bit by this button that I have to deal with, but that's okay. All right, so we got 6 is equal to, I'm just rewriting this, 5f, okay, over 6 minus 4f over 5. All right, so a lowest common denominator between, that's supposed to be D, between a 5 and a 6, that's got to be a 30, okay? So I'm going to multiply this equation. So I'm going to multiply this equation by 5. Oh, that doesn't really show up very well. Stick with tried and true, Mr. Smith. You have your favorite colors. Let's use purple. So to get a common denominator, whatever I do to the bottom, I'm going to do to the top. I need to multiply this by 5 to get to a 30. Now, conversely, on the other hand, I need to multiply this by a 6. Okay? Do you see, like, the question is complicated enough, and it doesn't have the patience for you if you struggle with fractions, like you just got to get good at fractions, right? You can't afford to stumble at this part of the problem. I think the problem is challenging enough. All right, so you have 25f on top. The bottom has now, you've achieved your goal of having a single denominator of 30. Subtract 6 times 4 is 24f. Well, this is going to work out nicely. This won't be too complicated at all, actually. So what do you have? 25 minus 24 is 1f, or just f, over 30. And of course, this is 6 over 1. I'm thinking cross-multiplying because this cross-multiplying is going to work out so beautifully. F times 1 is f. 30 times 6, 30 times 6 is equal to 180. And so that's the father's height, okay? The father's height must be 180. So at this point, I'm just going to create some room here. And let's just check everything, okay? Let's just check everything just for a brief half second, all right? You can always go back to the video and rewind if you need this information I'm erasing in green, of course. So let's check this now. So Alan was always supposed to be 4/5 of, now we know the father's height, of 180. Okay, so Alan is supposed to be 4/5 of means time, so we can just draw some brackets, 180 over 1. And so Alan is supposed to equal, well, I like to do pre-reducing. 5 goes into 5 once. 5 goes into 180. Oh, lordy. 36 times. So we have 4 times 36. 1 times 1 is 1. So all over 1 means the denominator went away. That's why I pre-reduced, because now it's no longer a fraction. 4 times 30 is 120, and 6 times 4 is 24. 154? 154. Yeah, that looks right. 4 times 3 is 120. No, it doesn't look right. Hang on a second here. 24 times 2. Whoops, 144. There you go. That time I caught my own mistake. 144. Okay. Yeah, 120 plus 24. Yeah, 144. So that's Alan. Okay, now let's talk Ben. Well, Ben is easy. Ben is Alan plus 6. So Alan is 144. Obviously, Ben is not that much taller. Okay. So Ben is supposed to be 150. Now, this is where you're really, really checking, because on the other hand, right? On the other hand, now let's look at the second last sentence here. On the other hand, right here, Ben is also supposed to be Ben is also supposed to be only 5/6 of 180. So we should get an answer of 150 here. Okay? So 5/6 times, of means times, 180 over 1. So 5/6 equals 180 over 1. All I did was use brackets instead of the multiplying. Look at this, grade 9. 6 goes into 6 once. 6 goes in there 3 times. 30 times, pardon me. 5 times 30 is equal to... Shocker! Okay, guess what I get to do for this question? You know what I get to do? I get to write it super big right over top of it. Yay. All right. Don't you love these word problems? I know you do. Okay, guys, till the next one. See you later.